Welcome to the series of lectures on fundamentals of organic chemistry. In previous videos, we have learned about isomerism and normal isomers. Under normal isomers, we have completed structural isomers and stereoisomers. Today, we are going to learn about dynamic isomers. Dynamic isomers are the isomers which are not stable at room temperature. These isomers are not stable at room temperature. What is isomerism? Isomers are the compounds which are having same molecular formula. Same molecular formula are known as isomers. Dear friends, isomerism is a phenomena where the compounds having same molecular formula and molecular weight are known as isomers, but they are different in the form of structural or spatial arrangement of the atoms. So these dynamic isomers are two types. These are two types. One is structural isomers, that is dynamic structural isomers, dynamic stereoisomers. All these dynamic isomers are not stable. They are interconvertible at room temperature. So they like flip flap. They change. They may be available in certain amount in some form and in other amount in other form. Let us see one by one. If I take structural isomers, what are structural isomers? The structural isomers which are same molecular formula, same molecular weight, but they are different in structure. Like when it comes to normal isomerism, so that structural isomers may be chain isomers, may be positional, may be functional, may be ring chain or metamers. These are all structural isomers. When it comes to dynamic isomerism, we can see this dynamic structural isomerism in these compounds. If I take keto-enol tautomerism or ethyl esteoestate, so this is keto form. This is keto form and it is stable in enol form. Dear friends, this is a 50-50 mixture of compound. This is a dynamic isomer. It may be asked in so many entrance exams. What is this isomerism? What is the isomerism of keto-enol form? What is the isomerism of keto form of ethyl esteoestate, and what is the isomerism of enol form of ethyl esteoestate? In any way this may be expected. This is very important. This is dynamic structural isomer. This is dynamic structural isomer. Next, dynamic stereoisomers. Dear friends, dynamic stereoisomers. These stereoisomers are interconvertible at room temperature. They are not stable, right? So these dynamic stereoisomers are obtained by single bond rotation. So these dynamic stereoisomers are not stable at room temperature. These are obtained by CC single bond rotation. For example, if I take ethane, this is ethane, right? So this is one carbon, this is one carbon. When I write this ethane into Newman projection, this, dear friends, this projection and other projections I will explain in next video under stereochemistry. Okay, let us see Newman projection. So this can be written as this way, and it is known as eclipsed form, right? So this can be written like this, CC bond. If I take this is the CC bond, if I rotate this into, so backward I am taking like this, I am rotating like this, back carbon, so I am getting this, right? I am getting this staggered. This is eclipsed, this is staggered. Which is more stable? Staggered is always more stable. Always more stable. These isomers are obtained by CC single bond rotation or conformational isomers. Dynamic stereoisomers are conformational isomers. Eclipsed and staggered are known as dynamic stereoisomers. These two are dynamic stereoisomers. These are not mirror images. Are they mirror images? No, they are not mirror images. Then what is the name given to them? Diastereomers. Right, friends? Again, these dynamic stereoisomers are divided into two types. One is enantiomer, another one is diastereomer. What is enantiomer? Enantiomer is a mirror image, but non-superimposable mirror image. Suppose if I take this N-butane, if I take N-butane CH3 N-butane and write it in a Gaussian form, it can be written as like this, Gaussian form. And what is the mirror image of this? So the mirror image is this Gaussian form in 300 degrees or 60 degrees. So the methyl group which is blue in this right side, it is coming towards left side. These are seems to be same, but these two are different. That is Gaussian 60 and Gaussian 360 is different. So these are mirror images but non-superimposable. What is non-superimposable? If I take this molecule and overlap on this, then is it same? No, this methyl comes here, right? So Gaussian 60 and Gaussian 300 of Newman projection are non-superimposable mirror images. So as per fundamental explanation, if the mirror image is non-superimposable, that compounds are known as enantiomers, right? So since these are dynamic in nature, because dynamic in nature, these are known as dynamic enantiomers, right? So what else? Dynamic diastereomers. Dear friends, diastereomers are the compounds which are not mirror images. So if I take butane, same butane, and write it in eclipsed form, that is 0 degrees, this is eclipsed form. Methyl is eclipsed on this, hydrogen is eclipsed. So how to write in Newman projection, I will explain in next video, right? So the same compound, if I rotate this methyl to here like this, then I will get this staggered or Gaussian. This is Gaussian form, Gaussian 60. So partial eclipse, this is partial eclipse, this is eclipse, methyl over methyl is eclipse, this is partial eclipse or 120 degrees. If I write in this anti form, right? So staggered form, this is methyls are opposite. Then just by seeing the structures, which is more stable? Because these methyls are opposite to each other, they freely move on in their space. So this is highly stable. Let us see energy differences. Dear friends, if I take the difference between 1 and 4, 4 to 1 is about 6 kilocalories. That means this is highly unstable, whereas this is staggered is highly stable. And same way, if I take 2 and 4, the difference is 0.9. Though it is staggered, it is stable, but this is more stable. This is more stable. 180 degrees staggered is more stable than 60 degrees staggered. Okay. Then if I take 3 and 4, this is eclipse. Obviously it is not stable. Staggered is stable. That is how order of stability of these diastereomers is 4 is more stable than 2. This is 2 is more stable than 3, and 1 is less stable. Among all these compounds, which is less stable? This is less stable. This is very, very important, friend. You can expect this question in any type of entrance exam. Even if you take CSR, IITG, mains, advanced, whatnot, JIPMAR, whatever exam you take, MSET, whatnot, all IITs, all CBITs, all CBSE, whatever it is, inter, degree, PG, wherever you go, this question you may get, which is more stable among these compounds, right friends? Always staggered forms are more stable than eclipsed. All these are diastereomers. Are they mirror image to anyone? No, all are different. So these are all diastereomers. Dear friends, dynamic isomerism is an isomerism where these compounds are not stable at room temperature. This is of two types. One is structural isomers or stereoisomerism. Structural isomerism where the compounds are structurally different, right? So these compounds, for example, keto-enol tautomerism. When it comes to stereoisomerism of dynamic compounds, these are not stable at room temperature. These are obtained by C-C bond rotation. C-C bond rotation. These isomers are also known as conformational isomers. Very, very important. Conformational isomers. Or these are staggered, eclipsed, and all these forms are seen in Newman projection. So dynamic stereoisomers are written in Newman projection and staggered forms are more stable than more stable than Gaussian form or eclipsed form. This is how dynamic stereoisomerism can be explained. Thank you friends. In next video I am going to explain about stereochemistry, which is advanced. Subscribe my channel, that is Venus Academy, for free, and don't forget to leave a comment or like. At the same time, please share these videos to your friends and colleagues. Bye. See you in next video. Thank you. Sayonara.